Welcome back to Basic Mathematics. In this video, we're going to be talking through the order of operations agreement, the rules that mathematicians use for analyzing mathematical expressions which contain chains of several operations together. We use these numerical expressions, and we'll see later on in the course variable expressions, in order to describe situations and give more robust tools for working with the sciences, economics, and other places where mathematics tends to be applied. But we start here at the beginning of the process. We'll spend some time getting familiar with the idea of an expression, getting familiar with the idea of the order of operations. Before I dive into some problems, the one thing that I want to stress to you is that it's very often better to take the time and write out more steps than you may think you need to at first. One of the most common mistakes that I see in students in this course is trying to do too much at once because the operations themselves are fairly straightforward, and then getting lost in the process and making a mistake with the order of operations because of that. So the order of operations involves 3 steps. But I like to think of this as a rule to evaluate operations in order of decreasing complexity. So addition and subtraction are the simplest operations that we have. You will see one of the big ideas in our work of signed numbers coming up next week, that addition and subtraction really are the same thing. So we have to treat them together. We will deal with addition and subtraction all in one step. More complicated than addition is multiplication, right? Multiplication is repeated addition. And division will go along with multiplication. Again, looking ahead a couple of weeks when we talk about fractions, one of the most important ideas in the lesson on fractions is that multiplication and division really are the same thing. Multiplication is repeated addition. 3 times 5 is the same thing as 5 plus 5 plus 5, right? 3 times 5 means 5 added to itself 3 times. Division, it turns out, is also repeated subtraction. If I take 12 and I subtract 4, and I subtract 4, and I subtract 4. 12 minus 4 is 8. 8 minus 4 is 4. 4 minus 4 is 0. Since I had to subtract 4 3 times, 12 divided by 4 must be 3. Right? So multiplication is repeated addition. Division is repeated subtraction. Because they are hiding addition and subtraction, multiplication and division are more complicated. And our rule for order of operations says we're going to have to deal with that first. And then we get to exponents and roots, which are the most complicated operations. Just like multiplication is repeated addition, exponents are repeated multiplication. Right? 5 raised to the third power means 5 times 5 times 5. Roots are a little bit trickier. Roots, I really don't have another way of thinking of other than the inverse of exponents for right now. For those of you who are moving onward to take more algebra after this, eventually you'll learn that roots in fact are exponents in disguise. They're just exponents where the exponent is a fraction, not a whole number, which is a bit of a nightmare and will be on what we want to deal with this semester. But the square root of 25 is 5 because 5 squared is 25. It might be worth knowing the list of perfect squares offhand as you're working through practicing multiplication. Those are kind of the easy ones. Right? 1 squared, which is 1 times 1, is 1. 2 squared, which is 2 times 2, is 4. 3 squared, which is 3 times 3, is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. You can keep going if you'd really like, but I think that's probably far enough. Recognizing that numbers are perfect squares is a nice thing to look at. And again, what I'm looking for here is not if I tell you, or if I ask you what is 5 times 5, that you can figure out the result is 25. What I'm looking for here is when I tell you I'm thinking about 25, immediately it should come to your head, oh, 25 is 5 squared. That kind of number sense is what we're looking for in order to prepare you moving forward into future mathematics courses. But anyway, we have now our 3 steps of the order of operations. We do the most complicated first, which is exponents and roots. Then after we're done with the exponents and roots, we go on to multiplication and division. And then once we're done with the multiplication and division, we go on to look at addition and subtraction. All right, so if I have something like 4 times 5 squared minus 9, according to the order of operations, the first thing I'm going to do is look at the exponent. 5 squared is 25. And the rest of the problem comes along for the ride. I don't have any exponents or roots left, so the next thing I look at is multiplication and division, which I happen to have right here. 4 times 25 is 100. And the rest of the expression comes along for the ride. At this point, I only have one operation left, 100 minus 9, which is 91. If the numbers are a little bit trickier, you may want to go off to the side of the page to work out each step of the calculation. For example, 7 times 14 squared minus 225. Well, it's the same process as the last one. I just changed the numbers, right? The three operations going on here are exactly the same. So the first thing I want to do is evaluate 14 squared. Right, 14 squared is not one I know offhand, but squaring means multiplied by itself. So 14 squared is 14 times 14. 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. Move over space, 14 times 1 is 14. Add those together, I get 196. Next, I'm looking at 7 times 196. I will again come off to the side of the page because I don't know what 7 times 196 is. I know estimating it will be really close to 7 times 200, which is 1,400, but I don't know exactly what it is. So let's go through and work through that. 7 times 6 is 42, right? The 2, carry the 4. 7 times 9 is 63, plus 4 is 67, right? The 7, carry the 6. 7 times 1 is 7, plus 6 is 13. So the exact answer is 1,372, really close to 1,400. And then one last step. Once again, I'm going to come off to the side of the page to work through the subtraction. 2 minus 5 doesn't work, so I borrow. 12 minus 5 is 7. 6 minus 2 is 4. 3 minus 2 is 1, and 1 minus nothing is 1. So I get a final result for this problem of 1,147. Right. This problem also really nicely illustrates what I was saying earlier. Make sure you're doing one step at a time as you evaluate an expression like this. In this particular expression, every single step involved the number that we calculated in the previous step. So it's important to make sure that you are performing those evaluations and getting the number in the previous step. So work through things step by step, one row at a time. There are situations where you can do 2 operations in a single step if they happen to be separated nicely. If you feel very comfortable, I'm not going to say you're wrong if you do that, but I strongly encourage against it because getting in the habit now, make sure you understand how these things work. And as you advance in mathematics, you can start learning where you can take shortcuts. Let's take a look at another problem. (72 minus 16 divided by 8 times 3 plus 5. The first step in the order of operations is to look for any exponents or roots. This particular problem does not have either of those things, so we move immediately on to the second step. Look for any multiplication or division. This problem does have some multiplication. It also has some division. So we have a choice to make. Which one do we do first? The rule of thumb for the order of operations is you read from the left to the right, and the first time you find that operation, that's what you do. So in this particular problem, the first thing I'm going to do is the division, which is the first thing I come to reading the problem left to right. 16 divided by 8 is 2. And the rest of the problem comes along for the ride. After that, there's only one bit of multiplication or division left. It's 2 times 3 here, which is, of course, 6. And the rest of the problem comes along for the ride again. And with that, we have finished all of the multiplication and division. We're now down to just addition and subtraction. Once again, we have some subtraction. We also have some addition. So we follow that same rule of thumb. Reading from left to right, we find the first addition or subtraction operation we come across, which in this case is this bit of subtraction right here. And we will evaluate 72 minus 6, which is 66. Carry along the rest for the ride. Now we're left with just one operation. 66 plus 5 is 71. Now that we've established the order of operations, the rule that you have to move from left to right and follow the operations in order, I want to mention the properties of addition and multiplication. There are several properties. Properties of 0 and 1 fall under this category. The fact that subtraction is the inverse of addition, division is the inverse of multiplication, fall into this category. But the ones that I really want to focus on are the commutative property and the associative property. My multiplication dots really looked like subtraction bars there. I apologize. Make sure those are very clearly multiplication dots. When you're dealing with addition or multiplication, we have a commutative property, which lets us change the order of those operations. We have an associative property, which lets us pick and choose when we have several of those operations chained together. The commutative property, not very often useful in dealing with expressions like this, although at the end of the semester, when we start talking about variable expressions, it's going to become very handy again. The associative property tends to be more worthwhile. If we have several bits of addition all chained together, and we happen to notice something that will make our lives easier, we can jump around. This particular problem is not that bad, but what I want you to notice in this problem is if we look at the second bit of addition, which is not what the order of operations says we should use first. Order of operations says the first thing we should do is figure out 27 plus 39. I don't know 27 plus 39 offhand, and it's going to be a little bit annoying. But I do notice here 39 plus 41. Specifically, I notice that in the ones place, I have a 9 and a 1, which all told will be 10. And one thing that I know for certain about operations on whole numbers is that the more zeros are in the number, the easier the process is going to be. So my instinct when I look at this expression is to use the associative property to allow myself to add 39 plus 41 first. 9 plus 1 is 10. 3 plus 4 is 7, plus 1 is 8. So using the associative property of addition, I can reorder and break the rule of moving left to right. And now I want to add 27 plus 80. And that's arithmetic I can do in my head, because the ones place, that 0, is going to make life so much easier on me. 2 plus 8 is 10, so 27 plus 80 is going to be 107, 107. When you're looking at multiplication, this becomes even more powerful. (42 times 9 times 36 times 0 times 95 times 26). Following the order of operations, I should need to first multiply 42 times 9, which is going to take quite a bit of work. It ends up 378. Then I have to take 378 multiplied by 36. That ends up something absolutely atrocious. I'm not even going to try. Because after I do that, I get to multiply by 0. And multiplying anything by 0, the result is 0. So if I multiply 36 times 0, which is not the first thing I should do in the order of operations, but because I can use the associative property, I can look at that first and multiply 36 times 0 and get 0. Then I can multiply 0 times 9, which is still 0. And then from here, I can follow the order of operations as it's written. The next step should be 42 times 0, which is 0. Then 0 times 95, which is 0. And 0 times 26, which is still 0. Did I have to write out all of those intermediate steps? No, not really. But for the sake of argument, explaining why are the commutative and associative properties useful? Well, they let you break the order of operations. For right now, again, the associative property is the useful one. The commutative property lets you write things out a little bit more nicely sometimes. And we'll be coming back and revisiting the commutative property along with another property at the end of the semester, which is going to make our life quite a bit easier. The other tool that will allow you to break the order of operations is a grouping symbol. Grouping symbols need to be given explicitly when you're going to use them. The most common grouping symbol is a set of parentheses. For example, 3 times the quantity 15 minus 7. I should mention here that notice there's no operation written between the 3 and the parentheses. Mathematicians are inherently lazy, and if we can avoid writing something out, we do. So when there's no symbol between the numbers, that means multiply. But here we have these parentheses, and there's subtraction going on in parentheses. Even though the order of operations says do multiplication before you do subtraction, the subtraction is in parentheses, so we do that first. 15 minus 7 is 8. And then we have 3 times 8, which is 24. We can chain together grouping symbols. For purposes of making things look a little bit nicer, if we have grouping symbols nested together, we tend to use square brackets. So here I have 7 times the quantity 12 minus 2 times the quantity 8 minus 5. And at this point, we look at the square bracket grouping symbol. Inside the square bracket is some parentheses. So the parentheses are going to be the thing we do first. 8 minus 5 is 3. The rest of the expression comes along for the ride. Inside the square bracket at this point, there are still a set of parentheses, but there's no operation inside those parentheses. So the parentheses are no longer acting as a grouping symbol. They're telling us to multiply. So we have subtraction and we have multiplication. The order of operations says that multiplication comes first. 2 times 3 is 6. Everything else comes along for the ride. One last operation inside the square brackets is the subtraction. 12 minus 6 is 6. And then finally, we have the square bracket here. 7 times 6 is 42. Again, when there's no operation between two numbers like this, we assume it means multiplication. The other place that you see something behave as a grouping symbol frequently is the fraction bar. Fraction bars mean division. You're going to take whatever's on top, you're going to divide by whatever's on the bottom. If there is stuff in there, you have to evaluate it first. So if I have something like 12 plus 3 times 5 divided by 13 minus 2 squared. Well, by following the order of operations, what we have to do is look at the numerator, the top of the fraction, and evaluate that. Look at the bottom of the fraction and evaluate that. Then bring those things back together. This fraction or this expression simplifies to 27 over 9. And again, fraction bars mean division. So once we have done that, we realize that this is telling us to take 27 divided by 9, which we know is 3. And with these tools of the order of operations, the ways that we can choose to break the order of operations, and the way that we can say to break the order of operations in an expression, you should be able to work through and solve the problems in the assignments and activities related to this. So take a look at those, and once you're feeling comfortable with that, I'll see you in the next video where I am going to start looking at using arithmetic as a tool for problem solving.